In 2025, Airbus delivered 793 aircraft. Their backlog stretches beyond 8,700 jets, sold out until the early 2030s. The aerospace giant is literally printing money, but here's what makes no sense. Despite record orders, despite airlines waiting 10 years for new jets, and despite billions in annual profit, Airbus hasn't launched a clean sheet aircraft since the A350, which was announced in 2004 initially as an A330 derivative. That jet entered service in 2015. The A320neo family that generates most of its revenue, a derivative of a 1984 design. Now, industry speculation points to Airbus's next move. Some call it the A360, others the A370. The question isn't just what to call it, it's what segment to target. A narrow body to replace the A320, a wide body to challenge Boeing 787. Perhaps both. The technologies under development, advanced composite structures, revolutionary open-fan engines promising 20% fuel savings, folding wingtips that would have been impossible almost a decade ago, could reshape either market. Meanwhile, Boeing is in crisis. Manufacturing problems, quality lapses, a balance sheet stretched thin. The window for Airbus to dominate the next generation of aircraft may never be wider. So, why hasn't it pulled the trigger? To understand why Airbus hasn't launched a new, clean sheet aircraft in over 20 years, regardless of segment, we need to examine what happens when manufacturers get clean sheet programs wrong. The aerospace industry is littered with cautionary tales. Airbus doesn't have to look far. Airbus invested more than $30 billion in developing the A380, betting that the future belonged to massive super jumbos, more than 500 passengers, major hub connections. The logic seemed sound. Airport slots were scarce. Runways couldn't expand forever. The solution was bigger aircraft carrying more passengers per departure. Emirates bought into the vision, made it work, but the market moved in the opposite direction. Airlines increasingly preferred smaller, more flexible wide-bodies, point-to-point routes, rather than congested hubs. Twin-engine aircraft that could serve secondary cities profitably. The 787 and A350 offered economics the A380 couldn't match on thinner routes. In February 2019, Airbus announced the A380 would be discontinued. Emirates, the aircraft's biggest champion, had reduced its order book. Without Emirates, the program couldn't survive. The final delivery came in 2021. The financial damage extended far beyond development costs. Airbus had constructed enormous facilities specifically for A380 production, specialized assembly infrastructure across multiple countries, custom tooling, trained workforces. All of it became stranded assets when production ended. These failures explain why Airbus approaches new aircraft with extraordinary caution. A new clean sheet aircraft today could cost $15 to $20 billion, perhaps even more than $30 billion. Interest rates have climbed significantly since the last major program launch. Shareholders demand returns. Every dollar spent on a speculative new aircraft is a dollar not returned to investors. The certification burden has grown enormously too. Regulators worldwide now demand more extensive testing, more documentation, more proof of safety. The 777X has been delayed repeatedly, as Boeing works through requirements that didn't exist when the original 777 was approved in 1995. Any new aircraft faces years of flight testing, thousands of test hours, intense regulatory scrutiny. The FAA's increased vigilance following the 737 MAX crashes means the next clean sheet program will face the most rigorous certification environment in aviation history. There's another complication. The global aerospace supply chain is currently broken. Boeing's manufacturing crisis has exposed vulnerabilities affecting the entire industry. Qualified suppliers for titanium forgings, advanced avionics, and precision machined parts are stretched to their limits. Engine manufacturers struggle to keep pace with existing programs, let alone ambitious new ones. Airbus's leadership has been explicit about this constraint. Guillaume Faury, the company's CEO, has repeatedly emphasized that technology must be mature before any launch decision. No commitment to programs dependent on propulsion systems that don't exist or supply chains that can't support production rates. The A320neo family demonstrates why Airbus is reluctant to disrupt what's working. This aircraft generates the vast majority of Airbus's commercial aviation profit. Production lines in Toulouse, Hamburg, Mobile, and Tianjin run at maximum capacity. more than 50 aircraft per month, 75 by 2027. Any successor would temporarily cannibalize these sales. Airlines might delay orders waiting for next-generation aircraft. Workers would need retraining. Production tooling worth billions would become obsolete. The transition risk is enormous, even if everything goes according to plan. And in aerospace, nothing ever goes according to plan. To understand what a future Airbus aircraft might actually be, we need to examine the technologies that could make it possible. The most significant breakthrough involves propulsion. CFM International, the joint venture between GE and Safran that powers most narrowbody aircraft, has been developing something called RISE, Revolutionary Innovation for Sustainable Engines. RISE is an open fan architecture, sometimes called an unducted turbofan. Traditional jet engines hide their fan blades inside a nacelle, that cylindrical housing hanging under the wing. Open fan engines expose much larger blades directly to the airflow, similar in concept to a turboprop, but operating at jet speeds. The efficiency gains could be substantial. CFM's targets more than 20% fuel savings compared to today's best engines. For an aircraft burning hundreds of gallons per hour, that translates into tens of millions of dollars in annual savings. But open fan engines create integration challenges. The exposed blades generate different noise profiles. Ground clearance becomes critical. Blade containment in a failure event requires entirely new design approaches. Noise certification and community constraints near airports could force late-stage compromises if demonstrators don't perform as hoped. The other potentially revolutionary technology involves wing design. Higher aspect ratio wings, longer and thinner relative to their chord, deliver significant aerodynamic efficiency. Less induced drag means less fuel burn. The issue is, making wings longer could restrict which airports the new aircraft can serve. Airbus has been exploring folding wingtips as a solution. The Boeing 777X already incorporates this feature, with the outer 11 feet of each wing folding upward for ground operations. Preserves aerodynamic benefits while maintaining gate compatibility. But folding mechanisms add weight, complexity, and maintenance burden. Every moving part is a potential failure point. The business case only works if drag reductions exceed the costs of additional inspections and operational constraints. Combining these technologies, open fan propulsion, high aspect ratio folding wings, and advanced composites could theoretically deliver a step change in operating economics. But each technology adds certification complexity, development risk, potential points of failure. But here's where the strategic picture becomes clear. These technologies could theoretically apply to either segment, a narrowbody successor or a new widebody. But when you examine the competitive landscape, one opportunity stands out. The A320neo, despite its 1980s origins, remains extraordinarily competitive. With over 8,000 orders, airlines clearly aren't clamoring for something radically different. The Pratt & Whitney geared turbofan and CFM LEAP engines already deliver significant efficiency gains. An open-fan narrowbody might offer another 20% improvement, but the development risk is enormous for a segment Airbus already dominates. The widebody market tells a different story. The case for a new Airbus widebody isn't about technological ambition, it's about market positioning. Boeing's troubles have created a window that may not remain open forever. The 787 should be Airbus's primary competitive concern. This aircraft dominates the mid-size widebody segment, 250 to 350 passengers on long-haul routes. Boeing has delivered well over 1,200 since the program began. Airlines love it. Airbus competes in this segment with two aircraft. The A330neo offers lower acquisition costs, but traces its fundamental design to the 1980s. Aerodynamic efficiency and structural weight simply cannot match a purpose-built composite aircraft. The A350-900 is more capable, but was designed to compete at the larger end of the widebody market, potentially over-spec'd and overpriced for routes where the 787 excels. This is where an A360 could target the 787's sweet spot directly. Think of it as an A350 optimized for a different mission, slightly smaller, more efficient, lower acquisition cost, purpose-built to capture routes where the 787 currently has no equal. Industry analysts suggest a hypothetical A360 family might include two core variants, a baseline seating 280 to 300 passengers in typical two-class configuration, competing with the 787-9, a stretched version carrying 320 to 340 passengers, positioned against the 787-10. The key would be avoiding cannibalization of the A350-900. Carefully positioning would leave larger A350 variants to compete against the Boeing 777X class, while a smaller A360 captures the mid-size market, where Airbus lacks a purpose-built competitor. But Airbus isn't just thinking about the smaller end of the wide-body market. At the Dubai Air Show in late 2025, Airbus commercial CEO Christian Scherer confirms what industry watchers had long suspected. The company is actively studying a stretched version of the A350-1000. Internally, it's already being called the A350-2000. When asked directly whether such an aircraft was in development, Scherer's answer was simple: yes. The concept would add fuselage plugs fore and aft of the wing, pushing passenger capacity toward 400 to 440 seats in typical configurations. That puts it squarely in 777-9 territory. The fuselage could stretch to nearly 79 meters, longer than any twin-jet flying today. Scherer noted that customer interest is coming from everywhere, not just one or two airlines. The demise of four-engine jets has left carriers like Emirates searching for alternatives. They operate over 100 A380s with no direct replacement. The 777X helps, but Emirates have been pushing both manufacturers for even larger twin jets. An A350-2000 would require a more powerful version of the Rolls-Royce Trent XWB-97 engine, additional emergency exits to meet certification requirements, and potentially some wing modifications. But critically, it would leverage the existing A350 production line and supply chain, evolutionary rather than revolutionary. The timing is strategic. Boeing's 777X has faced repeated certification delays, originally slated for 2020 and then targeting late 2025 as the earliest. An A350-2000 could potentially reach the market faster, given it would be a variant of an already certified aircraft rather than an entirely new type. So, the emerging Airbus widebody strategy becomes clearer: a potential A360 below, targeting the 787, the existing A350-900 and A350-1000 in the middle, and a stretched A350-2000 above, competing directly with the 777X, a complete family covering every segment where Boeing competes. There's another aircraft that should factor into this equation, one that Boeing has been talking about for nearly a decade, one that airlines desperately wanted: the Boeing 797, also known as the New Midsize Airplane, or NMA. Back in 2015, Boeing identified a gap in the market, something between the 737 and the 787, a twin-aisle aircraft seating 220 to 270 passengers, with a range of around 5,000 nautical miles, the sweet spot for routes too long for a narrow-body, but too thin for a full-sized wide-body. The concept attracted enormous interest. Boeing consulted with over 50 airlines, Emirates, United, Delta, Qantas, carriers across every major market expressed enthusiasm. The aircraft was meant to replace the aging 757 and 767 fleets still operating worldwide. Original plans targeted entry into service around 2025, a sixth-generation composite wing, advanced high-bypass engine, possibly an elliptical fuselage cross-section offering twin-aisle comfort with single-aisle economics. Then, the 737 MAX crashed twice. Resources that might have developed the NMA were diverted to fixing the MAX. The program was put on hold in early 2020. Then, the pandemic hit. Then, manufacturing quality issues consumed Boeing's attention. In 2024, Boeing announced that its next new airplane would be built in Washington state as part of a labor agreement, but the company hasn't confirmed what that aircraft actually is. Industry analysts don't expect any clean sheet Boeing program to launch before the 2030s, with entry into service potentially not until 2035 or beyond. Meanwhile, Airbus didn't wait. The A321XLR entered service in 2024, a single-aisle aircraft with extraordinary range, up to 4,700 nautical miles. Not a perfect replacement for the 797's twin-aisle comfort, but close enough for many routes. Airlines that once waited for Boeing's solution placed hundreds of orders with Airbus instead. United, American, Iberia, Qantas, the very carriers Boeing had courted for the NMA, now fly A321XLRs on routes the 797 was supposed to serve. The middle of the market, Boeing's market, now belongs to Airbus by default. Then we must talk about cargo operations. The air cargo market follows different cycles than passenger demand. Revenue stability during downturns, purpose-built freighters command premium prices compared to conversions. An A360F could serve as the modern replacement for aging 767 and A300 freighters still operating worldwide. The timing matters enormously. Boeing is capital constrained and operationally distracted. They're simultaneously fixing quality problems on the 737, ramping 787 production after years of disruption, and completing 777X certification. Their ability to respond with a clean sheet program is severely limited. Consider what Boeing would need to do. Design a new aircraft from scratch, secure board approval for tens of billions in development spending, rebuild supplier relationships strained by years of production chaos, all while their existing programs demand constant attention. If Airbus launches a new widebody in the next few years, entry into service would likely come in the late 2030s. Boeing would struggle to respond until the 2040s. That's potentially a decade of unchallenged market leadership in the most profitable widebody segment. A decade where every airline replacing aging widebodies has only one modern option. Sustainability regulations add another dimension. The European Union's emissions trading system already puts a price on aviation carbon. Similar schemes are expanding globally. Airlines face pressure from corporate customers demanding lower carbon options. Aircraft residual values now depend partly on environmental performance. An airline operating older, less efficient aircraft pays more in carbon costs. These costs compound over thousands of flights annually. When airlines evaluate fleet purchases today, they model fuel prices and carbon costs 20 years into the future. An aircraft with 20% better efficiency, it doesn't just save fuel, it hedges against regulatory risk. Airbus has linked its future roadmap to sustainable aviation fuel compatibility. Sustainable aviation fuel currently costs several times more than conventional jet fuel, but prices should fall as production scales. An aircraft optimized for higher SAF blends from day one gains competitive advantage as adoption mandates increase. With all of this, though, the hydrogen question looms in the background. Airbus invested significantly in hydrogen propulsion research, but in early 2025, the company announced it was postponing hydrogen aircraft development. What was targeted for 2035 has slipped, potentially into the 2040s. An A360 would almost certainly be a kerosene and SAF platform, not hydrogen. This delay actually strengthens the business case. If airlines and lessors believed hydrogen was imminent, they might hesitate to purchase new kerosene-burning aircraft with 30-year operating lives. Why buy a jet that becomes obsolete when hydrogen arrives? The postponement removes that concern. Efficient conventional platforms will remain relevant well into the 2050s. Belly cargo adds value too. Widebody aircraft generate substantial revenue from freight carried beneath passengers. On some routes, cargo makes the difference between profit and loss. The A350 already excels here, with excellent volume relative to its size. An A360 optimized for cargo flexibility could capture additional value that pure passenger economics don't reflect. Better container compatibility, higher structural payload capacity. Airlines operating competitive routes would gain an advantage that compounds across thousands of flights annually. Lessors represent perhaps the most important constituency. Leasing companies finance roughly half the global commercial fleet. Their appetite determines whether a new program succeeds or fails. When lessors commit to large orders, it signals market confidence. When they hesitate, manufacturers worry. Lessors care about remarketing potential. They want aircraft placeable with multiple airlines across different markets. A niche aircraft with limited appeal becomes a stranded asset if the original leasee defaults. The A360 would need broad appeal, capable performance across hot-high airports, reasonable runway requirements, competitive economics across diverse route structures. An A360 would likely share cockpit commonality with existing Airbus types, reduce training costs, easier fleet integration. Pilots qualified on A320 or A330 could transition with minimal additional certification. That stickiness matters enormously. Once an airline operates one Airbus type, the economics favor adding more. Spare parts commonality, maintenance crew familiarity, training infrastructure already built. This creates competitive advantage that outlasts any single program. So, if the widebody opportunity is so compelling, what happens to the narrowbody market? Airbus isn't abandoning its A320 family, far from it, but the calculus is different. The A320neo family will likely receive incremental updates through the 2030s, cabin improvements, aerodynamic tweaks, perhaps engine upgrades as CFM and Pratt & Whitney develop next-generation geared turbofans. These changes could extend the family's competitiveness without the risk of a clean sheet program. A true A320 successor, call it the A370 or whatever name emerges, would likely come later, perhaps the mid-2030s for launch, with entry into service in the early 2040s. By then, open fan technology should be more mature, supply chains recovered, the current backlog absorbed. The sequencing makes strategic sense. Launch the widebody first, where the competitive gap is widest, use that program to mature technologies and rebuild development capability, then apply those lessons to a narrowbody successor when the A320neo finally needs replacing. One clean sheet program at a time, the A380 taught Airbus the dangers of overreach. Fast forward to now, industry observers remain divided on whether a new Airbus widebody will materialize. Airbus leadership has carefully avoided confirming any program name or timeline. What they have confirmed is that technology maturation must precede any launch decision. Propulsion ready, supply chain capable, business case robust enough to justify billions in development spending. No one wants another A380. No one wants another 787-style delay. Guillaume Faure has described Airbus's approach as evolutionary rather than revolutionary. The next aircraft won't change everything at once. Proven architectures combined with a few step-change components, reduced risk while still delivering meaningful improvements. This is the lesson from decades of aerospace programs. Revolution sounds exciting in press releases. Evolution actually works. Open fan engines remain in development. CFM is working toward maturation milestones that could enable an engine generation available in the second half of the 2030s. That timeline broadly aligns with Airbus statements, suggesting the late 2030s for next-generation aircraft entry into service. The engine question may ultimately determine everything. If open-fan propulsion delivers 20% efficiency gains without unacceptable noise or integration penalties, the business case becomes compelling. If the technology falls short, Airbus might opt for a modest upgrade path instead, an advanced geared turbofan offering smaller but more certain improvements. The wildcard is Boeing. A new widebody launch from Boeing would force Airbus to respond, regardless of whether all technical pieces are in place. Conversely, if Boeing remains distracted, Airbus may choose patience over speed, waiting for optimal conditions rather than rushing to exploit a temporary opening. But with the 797 seemingly abandoned and the 777X years behind schedule, Boeing's ability to respond looks increasingly limited. The next clean sheet Boeing won't fly until the mid-2030s at the earliest, perhaps later. The strategic logic is compelling. Boeing is weakened. The mid-size widebody market lacks a purpose-built Airbus competitor. Sustainability regulations create tailwinds. Airbus has the financial strength and industrial capability to execute. But so did Boeing when they launched the 787. So did Airbus when they bet on the A380. The next Airbus aircraft, if it comes, won't be launched because Airbus wants to build a revolutionary aircraft. It will be launched because the economics make sense and the risks are manageable. In an industry where a single failed program can threaten a company's existence, ambition is subordinate to arithmetic. The question isn't whether Airbus can build a next-generation widebody, it's whether the numbers work. In commercial aviation, that's the only question that ever really matters. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?